Hello everyone. In this lesson we are going to explore the measures of central tendency and measure of dispersion by using the graphing calculator. So for the do now really easy question here, which one is an irrational number? So you could use your calculator for this, but square root of 9 you should know is 3, and that is rational. Perfect square. .14 is rational. Again, this is a terminating decimal. For C, square root of 3 is a non-perfect square. And that means it is irrational. So C is your answer. This is a fraction, of course. The ratio of two whole numbers is rational. And that is it. If you put square root of 3 into your calculator, we're going to press graph and clear. If you put square root of 3 into your calculator, second function square root and 3, you will get a number that goes directly to the end of the screen. And the only reason why it stops is because it's rounding. The calculator is basically showing all the numbers that it wants to show, and it rounds that last digit, and that's it. So in this lesson, how to find the mean, which is the mean is the average. The median is the middle number, using your graphing calculator. It's good. Like the mean, you could add up all of these numbers in the given data set right here, and you can basically add and then divide by those numbers, the amount of numbers, and then you would get your mean. If you want to do it just in the calculator, it's another way, like where I'm going to show you put your numbers into L1 and then it'll give you the answer. So the median is the middle number, and normally by hand you would actually have to set up write the numbers down from least to greatest and cross off each side. And I'm sure everybody's done that, but now we're in algebra, we're not going to do that. We're going to have the graphing calculator here to do that. This is the first method, and it's quick and easy. But I'm not going to use this method only because I really like the second method. And the second method is to press stat. And this is the same data set up here that you see, stat, and then enter. So that's what we're going to do. I'm just going to press this calculator, and I'm going to just put this down here, and I'm going to go to clear, and I'm going to press stat. And stat is right here. And you could see that right there, that I'm pressing stat, and then it's enter. So you see I have numbers from a different question. So I'm going to go up, and I'm going to go up to L2, and I'm going to press clear. Don't press delete, because then L2 will be gone. And press enter, and all the numbers are deleted at once. So do you see L1? I'm going to go up to L1, press clear, and that's it. So if you happen to go up to L1 and press delete, notice that the L1 is gone. So you are going to try to maybe press delete again and L2 will be gone, maybe reset the calculator, nothing brings that L1 back except for if you press stat and you see this number 5, it's called setup editor. And if you press it, it goes to the main screen and the setup editor, like it'll be there and then this will be blinking. You press enter and it says done. If I press stat and go back to edit, there's my L1 back. All right, and the L2. So make sure that that you know exactly what you're doing as far as that goes. So I'm going to move this down just a little bit here and try to move it up. So I'm going to put these numbers in all into L1. I'm going to press 13, enter. 3, enter. 10, enter. 9, 7, 10, 12, 8, 6, 3, 9, 8, 6, 3, 9, 6, 11, 5, 9, 13, 8, 13, 8, and 2 7s. So now look, I have, do you see L1 on the bottom? It says that it's waiting for the 20th number. I have actually 19 numbers in here. And if I put another number in, it would be the 20th number. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I am correct. I did not miss a number. Very, very important to do that. So now how do we get the median and the mode, and the mean, right? And the mode. And you could just do pretty much anything here. So this is the way you do it. You press your calculator and you press stat again. And then you go over to calc. And instead of going down, we've always used the linear regression number 4. We're not going to do that. We're going to just stay with one var stats, one variable stats, meaning there's just one list. And we're going to press enter once, twice for L1, frequency list, and then calculate. And then we're going to have all of this one var stats is going to come up. You see this X with the line on top? That is the mean. That is the average. And I'm going to round it to the nearest tenth. Nearest hundredth. So this symbol here is mean. And mean is average. So the mean and the average here is 8.21. The median is the middle number. Do you see it? You press down, and there's the median. It's 8. Median is middle. And that middle number is 8. And that's all you really want right now. Where like that's basically all they're asking for, the median and the mean. So that's all we're going to do. And that's how you would get that in your calculator. So the measure of central tendency is a single value that summarizes a set of numerical data. The mean is the sum of the set of data divided by the number of elements there are, a number of numbers. So you're just adding up 65, 80, 105, 300, and 350. and you would get the mean, or you can just go ahead and press Stat, Edit, clear that list, go up to L1, press Clear, see all the numbers are gone in L1, and then you press Enter. So I am going to move this over just a little bit. 5 CD players are priced at $65, so I'm going to put 65 in first. Enter. 80, 105, and 300 and 350. Just like that. It's 5 numbers, 5 CDs. Then I'm going to press Stat, go over to Calc, and use 1var stats, and Enter. And then there is your, on the top right there, it says X with the line on top. There is your mean. So what is the mean price? X with the line on top equals 180. It's $180. Now you could have just added the numbers up and divided by 5, but there's going to be other things that you're going to get from that, from putting in that like all of these numbers into a list. So I would just kind of practice doing that. So now we're going to talk about the median, and I'm not going to do this by hand. I am going to go to Stat, Edit. I'm going to go up to L1, press Clear, and then Enter. And notice that everything is gone there. So now I press 6, 8, 21, 29. 6, 8, 21, 29. The beauty of that is that you don't have to put it in order. 13, 21, 6, and 3. 13, 21, 6, and 3. And then the final number is 25. And we're going to press Enter. We're going to press Stat and go over to Calc and leave it on 1var stats. Press Enter 3 times, and we are looking for the median, which is the middle number. And the median is 13. The middle. The median equals 13. I'm going to bring the calculator back up, go to Stat, Enter, clear it, go up to L1 and press Clear, Enter. Then we have 46, Enter, 50, 41, 43, 52, 45. Press Stat, go over 1var stats, Enter 3 times, and we're going to go down a little bit, and there's the median, 45.5. Let the calculator do everything for you. So the mode is the most common. You don't need a calculator for this. Most common. So we are, I don't like that. Yep. So we're going to just put most here to remind ourselves of, we're looking for the frequently used number. So this is 9, 2, there's 2 10s, there's 2 9s, there's 3 9s. So 1, 2, 3. 3 9s, there's only 2 10s. So 10, C, for C, the mode is 10, is 9. So let me show you a little bit of a trick that, the calculator will do for you. If you put this list in, say C, right? We already know that the mode is 9 because it was used 3 times. So I'm just going to put 9 in. I'm just going to put this list in and press enter. And then 2, enter, 10. Like say if it's a long list, you don't want to look to see like what number is used twice or 3 times. So I'm putting in all of the numbers in this list, right? So there's 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I could press, if I go to stat and I'm looking at this right here, this number 2 is you could sort the list in an ascending manner. Ascending means it's rising, right? From lowest to greatest. Descending means greatest to lowest. Descending. So it's decreasing. So I'm gonna sort the list so it's ascending, right? From least to greatest. So what I do is I have to put what list I want to be the calculator to rearrange these numbers. So I press second function like I did here. L1 is 1. Do you see that? And if I press enter, it's going to say done. So then once I go back to the list, do you notice that it's ascending? So 2, 3, 4, 6, 7, 9, 3 9s and 2 10s. So just take a look. 9 is the mode. D, I don't need to see anything as far as this goes because there's so little numbers. I'm not putting this into the calculator. 14 is used twice, so the mode is 14. E, the mode, and I see no mode. That's because no number is used any more than the other. So now look at this right here. This is what I'm talking about. So I'm going to bring up the calculator, right? So I'm going to bring the calculator over here. I'm going to move this over. And I'm going to go up and I'm going to clear out that list. And I'm going to input 10, 2 8s, 1 4, 1 2, 1 15, 1 17, a 20, and a 15. So now I'm going to go back to stat and I'm going to press 2 for sort ascending. So I'm going to press second function 1 for L1, and let's see if I press enter, it's done. I don't have to close the parenthesis, it's done. Stat, and then enter again, and now the list is ascending, and I could see that 8 is used twice, and so is 15. So if 8 is used twice and 15 is used twice, the mode is 2 numbers, 8 and 15. And you could see it easily, as this is sorted from least to greatest. And that is something that I think is useful when you have a longer list, not something like D, where you could just, take a look at the data set and it has 5 numbers and you could see 14 is used twice. All right, and that is it. So here's some Regents questions. The table below shows the annual salaries for 24 members in a professional sports team. Just realize that there's 24, and when you're putting these numbers in, that you'll have the 25th team like next, but there won't be anything else after that. So if you have, say, if you miss a number and it's waiting for the 24th number, you automatically know that you did miss a number. And if you miss a number, everything is going to be wrong. With this next question, the 24 members of the professional sports team, all of these numbers go directly into the calculator in one list. So I'm just going to bring up the calculator and I'm just going to put all of those numbers in one list. So 0.5, 1, 1.4, 4.2, 5, 0.5, 1, 1.8, 4.6, 0.6, 0.6, 1.1, 2.5, 5.1, 0.7, 1.25, 3.7, 6, 0.75, 1.3, 3.8, 6.3, and then the last row, the last column, 0.8, 1.4, 4, and finally 7.2. So it's waiting for the 25th number, and it's 24 members. You know that they said it in the question. So that's a good thing. So I didn't skip anything. So I'm going to press Stat, Enter, Stat, go over to Calc, leave it on 1var Stats, and then press Enter 3 times, and we get all of these numbers here. So when we have this, they're asking us, let me put this down here, a team signs an additional player worth $10 million per year. Which statement about the median and the mean is true? So right now, the median and the mean. So I'm just going to put this down, and I'm writing in highlighter, so that's no good. I'm going to put down what the median and the mean is originally. So the median originally is 1.4. The mean, which is the average, which is that X and the line on top, which should be all the way up, is 2.5625. 2.5625. 2.5625. Now I'm going to add another contract of $10 million. And that is going to be specifically adding 10, right? So like you're adding a 10. These are all in millions of dollars. This is 1 million. This is 4.2. 6 million. So we're going to add a 10. So I'm going to go back to the stat. I'm going to press enter. And then I'm going to go all the way down. And do you remember that it was waiting for another member? Oh, I didn't have to go all the way down. Obviously, I could just go up. And then it would go to the 25th. I don't know why I was going down like that. But 10 million. We're going to add it. And then we're going to enter. And then we're going to go back to stat, calc, 1var stats, and then we're going to press calculate. So now, let's go back. This is 2.86 now. The mean. 2.86. And the median is 1.4. Now I can answer the question. Team signs an additional player worth $10 million per year. Which statement about the median and mean is true? Both will increase? No, that's not true. Only the median increase. No, the median stays the same. Gone. Only the mean will increase. Yes. This is true. And it says neither will change. That is false. So that's how you do that problem. Take it step by step. Write down everything, and that's it. So an amusement park hires students for the summer. Find the mean, median, and mean, median, and mode of the hourly wages. So this is pretty easy because all you have to do is just put the numbers into the calculator. The student hourly wages are right there. So we're going to press stat. We are going to clear that giant list out. We're going to go up to L1, clear everything out, and press enter. So we're going to have 3.87, enter, 8.75, enter, 8.25, 6.99, 7.25, 8.45, 7.25 again, and then 7.99. So we're going to find a whole bunch of things here. We're going to enter, and we're going to go over to calc. We're going to leave it on 1var stats. We're going to enter it 3 times, and there it is. That's the mean, 7.35. We'll move this over, and I just wanted to put that it was X with a line on top equals that. And then we're going to go back to the median, 7.62. And what's the mode? If you wanted to, if you really wanted to, you press stat and you sort this list. The list is in there already. You press second function L1 and you press enter. It says done. Then you go back to the list and you look at it and say, okay, 725 is used twice. So 725 is the mode. And that is that. So it says find the range and the mean of the data sets. So it's 25, 230s, 47, and a 28. So I'm going to bring this up, I'm going to go all the way up and press clear, enter. And we're going to add the 25 to the list. the 30, another 30, a 47, and a 28. And now we are going to press stat and then go over to calc, leave it on one var stats, press enter 3 times. And there are our numbers. So we have range and mean. So the mean is 32. The range is the largest number subtracted by the smallest. So we are going to go back and press stat, and we are going to sort this list 2, and we're going to go down to L1 and press done to sort this list. And then we're going to press enter, and you can see right here that 47 is the largest minus the 25, which is the smallest. Largest minus smallest. And we have, let me just move this up if I can. No. Largest minus smallest. And those two numbers are, and you take a look at your list, it's 47 minus 25. And that equals 22. And that's it. So the mean, just going to go back up, and we are going to clear that list. And we're going to put 34, 28, 31, 36, and another 31. Press stat, go over to calc, leave it on one var stats, press it 3 times, and the mean, which is x, with a line on top, equals 32. The range, we're going to go back to stat, and we're going to sort that ascending. Go to second function L1. We're going to press done. We're going to press enter, and that's going to say done. And then we're going to just look at that list, and it is 36 minus 28. 36 minus 28 is 8. And that is it. So it says, what can you determine from the mean and range of each data set? So we're going to put the means are the same, and there's different ranges. And the means are the same, and the range is much larger in data set I. That means if the range is larger in data set I, the numbers are more spread out in that data set. And that's really the whole thing. So here's the mid-lesson assessment, which statement is true about this data set. They ask mean, mode, mean, median, mean, median. So we have to go ahead and put all of this into the calculator to get all of these numbers. So we have this data set right here. We're going to make this a little bit bigger, and we're going to put 3, 4, 5, 6, 2 7s, and a 10. So again, I count the numbers. That's 7 numbers there. And that's 1, 2, 3, 4, 5, 6, 7. I didn't miss anything. So let's go ahead and press stat and then calc. And we're going to go to one var stats and press enter a whole bunch of times. So the mean is 6. So I'm going to go and put the mean is 6, 6, 6, and 6. All right, the mode. All right, I could put this in ascending order to figure out the mode, or I could just look at it. But let's go ahead and just get practice at putting this in ascending order. This is L1. We're going to press enter. That's done. And we could just look at the list. So 3, 4, 5, 6, 7 used twice. So the mode is 7. Does this equal this? No, it does not. So we could get that out of there. Does the mean of 6, is that greater than 7? No, it's not. The mode is not asked again. So we're just going to go for the median. And the way we get there is just go to calc and leave it on 1 var stats and press calculate. The median is 6. So I could put 6 and 3. They're equal to each other. This one is true. This is not. All right. And that's how you do it, one step at a time, using the calculator to compare numbers. Here's another regions question. Isaiah collects data from 2 different companies, each with 4 employees. The results of the study is based on each worker's age and salary is listed in the tables below. So here's the age, here's the salary of each of the workers. So it just wants you to use the data in the tables to choose a true statement based on all of this. So they're talking about the median salaries of both companies. The mean salary in company 1 is mean salary. We're talking about salaries only. Salary range. And then the mean age of the workers. So the worker's age is not in these choices except for choice 4. So I'm not going to worry about the worker's salary, the worker's age, until I really am trying to get number 4 to cancel out. But I'm going to just go ahead and put into the calculator just the salaries. And that would help me out big time. I'm clearing out that list and I'm going to put those salaries in. And I know it's a little bit difficult to see, but it's a little bit better for me to type 32,000 and then enter. And then 35,000 and 38,000. Let's see if I can get a lot of information about this. So now I'm pressing stat and I'm going to go over to calc and I'm going to leave it on 1 var stats and then press enter a number of times. And let's see the median salaries. So let's talk about the median salaries of, this is just company 1. So I'm going to put company 1 has a median salary of 33,500. Okay, so that's company 1. And then median salary, the mean salary is 30 of company 1 equals 33,750. All right, the salary range would be the smallest. I'm going to sort them in second function L1. And the salary range here is 30,000 to 38,000. So this is already sorted. So we could just subtract 38,000 and 30,000, and the range is 8,000. So I moved it over. Company 1 has all this information. So now company 2, I'm going to put median. I'm going to put the mean, And then I'm going to put the range. And I'm going to pick the calculator back up, go to L1, clear that out. And again, 29,000. Enter. 35,500. Enter. 37,000. Enter. And then 65,000. Enter. Now I'm going to go and, you know what? I'm going to just go to Calc and press 1var stats and just make this what it is right there. So company 2, going to move this over. The median, the mean, we just put that in, it's 41,625. The median is 36,250. And the range is 65,000. Let me clear this out. 65,000 minus 29,000. Right? Yeah. Enter. So it's 36,000. Wow. All right. Which one is true? Now we have all of the information. So the median in both companies is greater than 37,000. This company 1 is not greater than 37,000. That's out. The mean salary in company 1, the mean is 33,750. Is greater than the mean salary in company 2. No, it is not. That is false. The salary range in company 2 is tremendous. The range is 36,000. Greater than the range in company 1 of only 8,000. That is true. There's no reason to get the ages involved, because the salary range, company 2, is much greater. So you do have to take it step by step, just like that. Don't worry about the ages. Just do the salary in dollars. So standard deviation, this is the last thing in this lesson. Standard deviation tells you how far a value is from the mean. And lowercase sigma is the symbol for standard deviation. A low standard deviation means that data is closely related to the mean. That means that there's not as much spread, and the mean, the average of the whole data set and the numbers that are in that data set are not that far apart. A high standard deviation means that the data has a large difference in relation to the mean. So we're going to see what this means. Standard deviation is a measure of how spread out the numbers. So the more spread out, the further those numbers are away from the mean, the larger that the difference is from that mean. It's not a good representation. The closer the numbers are to the mean, then that means there is a pretty good representation of the mean and that data set. So the low standard deviation, when it has a lower standard deviation, it means that the numbers in the data set are closely related to the mean. A higher standard deviation means that there is a large difference in relation to that mean. So standard deviation on the calculator is the same way. You press stat, you choose edit, you enter your list into L1, 1var stats, and you could see I put this up on here. When you're talking about this, if you press stat and enter, See this list here? If you press Stat and go over to Calc, and you leave it on 1var stats, well, and you press Calculate, you see this right here? That is standard deviation. And it's 13,826. So you're just looking and saying, wow, that kind of seems like a lot. Well, yeah, that's because look at the spread of numbers. It starts at 29. The range is tremendous. So these numbers are not fully represented. That doesn't fully represent the mean of this whole data set, because this 29,000 is well below the mean. And this 65,000 is well above the mean. So that's why it has a larger standard deviation. So mean is the X with the line on top. The standard information is not needed here, like in that section, but the standard deviation is right here. This is standard deviation with that Greek letter sigma. And then now we're just going to practice. We're going to practice and calculate the mean and standard deviation of each. So I put these numbers into the calculator here, and now I'm going to press Stat, and I'm going to go over to Calc, leave it on 1var stats. We're going to press Enter 3 times, and the mean is the X with the line on top. So I'm just going to put the X with the line on top equals 92.5. And the standard deviation is 2.87. So sigma X is equal to 2.87. Now that is a small standard deviation, so going back to this list here, the smaller that standard deviation is, going back to here, a low standard deviation means that the data is closely related to the mean. So just take a look at what we have here for the first. See this 92.5, the mean? All of these numbers are closely related to that mean. So that means that standard deviation is a lower number, right? Because it's a good representation. So I'm just going to move this over here. And we're going to put 100 in, 60, 98, 98 again, 99, and 100. Then we're going to press Stat, and then we're going to go over to Calc and 1var stats and enter 3 times. So the mean, which is X, line on top, equals 92.5. Now, I don't know why I put 9.2. $92.5. Now, just looking at that mean, you see this 60 and this 100? The 60 is kind of low, so I bet you this standard deviation is a little bit is higher than this. It's greater. I guarantee it. So let's go down and see, there it is, 14.55. So we'll round this to the nearest hundredth, 14.56. And it is larger because of this 60. That 92.5 mean and this whole data set, the data set is a little bit more spread out, and that means the standard deviation doesn't represent the mean like in the first set. And that really is telling. A larger standard deviation, the numbers are more spread out and doesn't represent the mean as great as the standard deviation of 2.87, where the numbers are kind of like, get clustered around that mean. So what does this standard deviation tell us? Well, the larger standard deviation it means that in set B, that set does not represent the mean well. It is not a reliable set of numbers where we're talking about the mean. We don't know what the next number would be. But in set A, that represents the mean in a little bit closer fashion. In other words, it is definitely more reliable. And that's it. Is there an outlier in set B? If there's an outlier in set B, it is definitely, and I'm going to say yes, and it's definitely 60. That is the outlier. Does it affect the standard deviation? Yes, it does. Well, how does it affect the standard deviation? And I just put, if 60 was not in the data set, the set would closely represent the mean, that data set B. The standard deviation would definitely be closer to 0, right? If that 60 is gone, that would really mean that the mean would increase just a little bit, and the standard deviation would decrease down to close to 0. And it would definitely be more reliable. And that is it. So which data has the greatest standard deviation? So you could figure this out where you could put this into the calculator, or you could just look at it and say, okay, the greatest standard deviation is the set that is the most spread out. The smallest standard deviation would be a set where it is closely related to the mean, where it's a good representation of what that mean would be. So just looking at it, the greatest standard deviation would be B, just looking at it. And just remember, you can put this directly into the calculator. 13 would be the first number, then you put 4. 14's 15, 7 times 16. So the mean would be 15, and the standard deviation would be 1. This standard deviation, if you did that, the mean would be 15 as well. And the standard deviation, since it's so spread apart, the standard deviation of X would be 1.6. This one here, if you put this directly into the calculator, again, the mean is 15, and the standard deviation would be equal to 0.7. This one is the closest to the mean, so it's the least. This is the greatest because it's further away, it's spread away from that mean. Okay, so in which office are you more likely to wait 20 minutes or more? So the doctor's office is here. It's the mean wait time is 15 minutes, but the standard deviation is 2.5. The cat's office, I don't understand it, but the cat's office, 15 minutes. The standard deviation is 5.5 minutes. So which one would you likely to wait 20 minutes or more? Well, the one with the higher standard deviation means that it is more spread out, the more chance that you have to wait more than 15 minutes. And I put that there, and you are more likely to wait 20 minutes or more in the cat's office because of the larger standard deviation. All right, so here we go. The two reality cooking shows, they have 12 contestants each. The ages of the contestants are shown in the tables. Find the standard deviation of the ages in show A, and then find the standard deviation of the ages for show B. So I put these into my calculator and I found that the standard deviation for show A, all of the ages, is the standard deviation is 4.203, which isn't terrible. The standard deviation of the ages for show B, in example 1, is 7.472. So that means that the ages in show B are more spread away from the mean. So that's exactly what I put for compare the standard deviations in show A and show B. The contestants in show B represent a wide spread of age, a wider spread of age than in show A. The ages have a larger spread away from the mean. And in this final question, we're talking about the Team A. Two different sets of data below represent the number of runs scored by two different youth baseball teams over the course of a season. So we're going to just grab the calculator, and I'm going to put this like this so I could see exactly what's going on here. And we're going to go and press Stat, Edit, and we're going to clear that out just like that. So I'm just going to put 4, 8, 5, 12, 3, 9, 5, and 2. So then when I press Stat, let me just go down and see its mean, standard deviation, and that's it. So I'm just going to put Team A over here. Mean, which is X, with a line on top, and sigma X for standard deviation. Team B, X for the mean and standard deviation. Okay, so Team A, we're going to press Stat. Right, just like that. We're going to press Stat, press Calc, Enter, and we're going to click that 3 times, and the mean for the first team is 6. And the standard deviation is 3.16. So 6 and 3.16. Now I'm going to go down to team. I'm going to press Stat again. I'm going to press Enter, and I'm going to clear out this list, this L1. And I'm going to just go ahead and put 5, 9, 11, 4. 5, 9, 11, 4, 5, 9, 11, 4, 6, 11, 2, 7, 6, 11, 2, 7. So now I'm going to press Stat and go over to Calc and leave it on one var stats. We're going to enter, and we are going to put the mean in as 6.875. The standard deviation is 3.06. All right, here we go. The mean of A is 6. The mean of B is 6.875. So that's true. The standard deviation of A is 3.16. Is that greater than the standard deviation 3.06? Yes, it is. So this is your answer, number 1. And that is true. Let me just go ahead and look at the rest of them because that was just too easy. Standard mean A is of Team A is 6. Team B is 6.875. 6.875. So 6 greater than 6.875, this is false. No need to check the rest of it. So mean A is 6. The mean B is 6.875. That part is true. But is the standard deviation of A 3.16 less than the standard deviation of 3.06? That's false. And that's out. And then the last one that we're going to do, standard deviation, the mean of A, which is 6, is that greater than 6.875? No, it's not. And that's false. And that's it. So 1 is your answer. And that's it for the lesson. So just remember, one thing that I did want to mention is that, like I did this question, the regions has you go back and forth, right? So look at your choices. What are they asking you to compare? They're asking you to compare mean and standard deviation, mean and mode. We've seen a lot of different questions here. So make sure that you are looking at the choices, and then you could go and put team A in, get all the information, then put team B in, get all the information that you need, just so you can compare and contrast the two things that they want. Sometimes it's 3 things, right? Sometimes it'll be mean, mode, and standard deviation, but you never know until the question presents itself. All right, and that is about it. Hopefully this helped, this video. If not, then all right, so be it. I don't know. But if it helped, that is a good thing. But as always, thank you for watching, and I'll see you next time. Bye, everybody.